In the lush jungles of western Honduras, near the border with Guatemala, lies Copan, a city that was once a vibrant heart of the ancient Maya civilization. Over 1,000 years ago, its towering pyramids, intricately carved stone monuments, and bustling plazas were rich with the sounds of a thriving society. But around 1,200 years ago, this city faced a mysterious collapse, leaving behind ruins that have puzzled scholars for centuries. What caused the downfall of Copan and the broader classic Maya civilization? Was it environmental catastrophe, social unrest, or the clash of cultures? A new study offers fresh answers through the analysis of ancient DNA. Researchers from Trinity College Dublin have analyzed the DNA of several individuals buried during Copan's heyday. The results have uncovered new clues about the rise, composition of the population, and most crucially, the eventual decline of this civilization. Copan was no ordinary city. From around 250 to 950 AD, during what archaeologists call the classic Maya period, it was a major capital at the southeastern edge of the Maya world, a crossroads linking Central and South America. Its story begins even earlier, in the early pre-classic period before 1000 BC, when small farming communities settled in the Copan Valley, relying on maize, a crop so central to Maya life that their myths describe humans as being molded from it. By 426 AD, a pivotal moment arrived with the founding of a royal dynasty by Kinich Yaks Kukmo, a charismatic outsider whose origins are shrouded in mystery. Ancient inscriptions tell us he arrived in Copan in 427 AD, establishing a lineage of 16 rulers that governed for nearly 400 years. Under their rule, Copan flourished as a hub of art, astronomy, and trade. Yet, by AD 820, the city's political system crumbled, its grand construction projects ceased, and its population dwindled. The new DNA study sheds light on this particular arc. The researchers focused on 7 individuals buried during the Classic period. Their remains were excavated from Copan's archaeological sites as part of the project. Among them were 2 men whose burials tell contrasting tales. One, known as CPM-13, was laid to rest in a lavish tomb outside the city's Acropolis and was surrounded by precious grave goods like jade and pottery, suggesting he was a member of the ruling dynasty. The other, CPM-12, was found nearby in a position typical of a sacrificial burial, possibly offered to honor the gods or seal a political pact. These 2 men shared a Y chromosome lineage called Q1b, a genetic marker passed down from father to son, like a family name carried through the male line. This Q1b lineage is common among indigenous American populations today. Yet, despite sharing this marker, they were not close relatives. The other 5 individuals, 3 women and 2 men, showed diverse maternal lineages belonging to mitochondrial DNA haplogroups called A2 and C1. Mitochondrial DNA, inherited only from the mother, is like a maternal family tree, and A2 and C1 are widespread across the Americas, suggesting that women from varied backgrounds were part of Copan's community. To uncover Copan's genetic story, the researchers compared these 7 genomes to a vast data set of ancient and modern DNA from across Siberia, North America, Central America, and South America. Their analysis revealed a remarkable continuity. The people of Copan were genetically linked to populations in the Maya region as far back as the late Archaic period, around 5,600 to 3,700 BC. This ancestral thread connects Copan's Classic period inhabitants to earlier groups in Belize, later Maya from Chichen Itza, Maya from Campeche, and even the 7 million Maya living today across Mexico, Guatemala, Belize, and Honduras. But Copan's story is not just one of continuity, it's also one of change. The DNA data uncovered an influx of ancestry from highland Mexican populations, likely from regions like Oaxaca, home to the Zapotec people. This genetic influence began during the early to middle Classic period, around 250 to 550 AD, and grew stronger in later Maya populations, such as those at Chichen Itza. At Copan, highland Mexican ancestry made up about 6% of the genetic makeup, suggesting that newcomers, possibly elite members of a broader Maya network, integrated with the local population. This aligns with archaeological evidence of Copan's extensive trade and political ties with cities like Tikal in Guatemala and Teotihuacan in Mexico. Isotopic analysis, which studies chemicals in tooth enamel to reveal where a person grew up based on their childhood diet, further supports this picture, showing that many of Copan's elite were born elsewhere before settling in the city. Kainich Yaxkugmo himself may have been one such outsider, his arrival marking the start of a dynasty that blended local and foreign influences. This blending of local and foreign elements likely enriched Copan's culture, producing its stunning art and architecture. But it may have also introduced tensions during times of crisis. The DNA data also tells a story of population growth and decline. Using a technique called identical by descent, IBD analysis, which looks at shared DNA segments to estimate how closely related people are, the researchers found that Copan's population grew significantly during the Classic period, reaching an effective size of about 19,000 around 730 AD. This effective size reflects the number of people contributing to the gene pool, not the total population, which was likely larger. This boom was likely driven by the spread of maize agriculture, which allowed the Maya to support larger communities. Maize wasn't just a crop, it was a way of life. However, this population explosion in turn put immense pressure on the agricultural system. The fertile Copan Valley, reliant on maize, struggled to sustain such numbers, especially as the fields were pushed to their limits to feed the city's residents, from laborers to elite rulers. This strain on agriculture had set the stage for Copan's vulnerability, and the genomic data points to a sharp population decline starting around 750 AD, coinciding with the collapse of the city's political system by 820 AD. But agriculture alone likely wasn't the only factor in Copan's fall. Other factors compounded the crisis. Severe droughts, dated between the 9th and 11th centuries, likely devastated maize crops, as relentless heat and scarce water left fields barren. These environmental stresses, documented in archaeological records, would have deepened food shortages, threatening the survival of a population that was already stretched thin. Political instability also played a role. As rival Maya city-states like Tikal and Calakmul competed for power, Copan's dynasty may have struggled to maintain control, with alliances fraying and conflicts erupting. Social tensions likely added to the strain, as inequalities between the elite, living in opulent palaces, and commoners toiling in the fields grew. The lavish tomb of CPM-13, filled with riches, contrasts starkly with the simpler burials of others, hinting at a society where wealth and power were unevenly distributed, possibly fueling unrest. The broader implications of this research extend beyond Copan. The Y chromosome lineage, Q1b, found in Copan's male burials, ties the Maya to the first human migrations across the Bering Land Bridge over 15,000 years ago, when early peoples crossed from Siberia to North America. The mitochondrial haplogroups A2 and C1, shared by Copan's inhabitants, are part of a Pan-American genetic legacy that spans from Alaska to Argentina. Despite its groundbreaking insights, the study has limitations. Future research, with more extensive sampling across Copan and other Maya sites, could reveal regional and temporal variations, offering a fuller picture of the civilization's rise and fall. As ancient DNA technologies advance, targeting epigenetic markers, pathogen DNA, and proteomic residues, we stand on the cusp of deeper insights. We could detect trace signatures of drought stress on DNA methylation. We might also reconstruct the oral pathogens that traveled along trade routes. We can also chart micromigrations within the Maya world from village to capital. Thanks for watching. If you enjoyed, don't forget to like, subscribe, and drop a comment below with your thoughts or questions. We love hearing from you. Until next time, keep exploring.